Greetings, cs245 people. Time for another Glassboard video. We're going to explore the mysteries of our struct node. Okay. A struct node, a struct, is a lot like, or a little bit like, an object. And in particular, like a class. They use the terms in different. So the structured declaration here, declaring this struct here, is like declaring the class. And then when we're done, we can declare variables which contain a struct. So that would be an object. Or we can declare variables which are pointers to a struct. And we tend to do both. So let's start with struct node is going to make a class of type. Well, we could say node, but it's usually in C that people will say struct node. Either way, people will understand it. So this is like declaring a node class, just like you did for your linked lists in 158, or maybe EC 252, the same thing. And inside of this class, we have data. And C is not really object-oriented. You don't actually have methods in your class. All you have is the variables for the instance variables for the data which is inside the object, in this case inside the struct. And inside of this we have two things. One of them is a variable called next. Next is a pointer to another node, struct node. The other thing we have is an array of size. Well, we know this is 101 because we know that this is the preprocessor is going to replace max string with 100. So we have an array of 101 long of character. So those are the two things that are inside this objects of type node. Inside struct node objects. Memory objects. Okay? And then we're going to have another variable here we're calling new node. New node is a pointer to struct node. So one thing we did not declare any actual struct node variables. We could have, but we didn't. Instead, we're going to do something like you would do in an object-oriented language and make a new one. Okay? So instead of calling new as in Java, we're going to have to do malloc. Malloc stands for memory allocation. Memory allocation. Got it? And that's a library, subroutine that you can call. Function, method. And we need to give it the number of bytes. So do we know how many bytes are in this struct node? Well, we don't. We can sort of take a guess, because this is going to be 101 bytes, right? But this pointer here, this variable holds an address. Actually, on different machines, you'll have addresses are different sizes. So we don't actually know how big this is. Okay? But we have this cute little size of, which is another preprocessor. Okay? So during preprocessing time, at the same time that this max string is replaced by 100, this will replace this argument here by the number of bytes in a struct node object. So since we did this up here, the compiler knows how big a struct node object is going to be. And size of struct node means tell me how big that object is at preprocessor time. And it puts that number, let's just say that's 110 or something like that. Okay? Approximately 110. So it'll be approximately 110. And it will call the malloc routine and say, get me 110 bytes, or however many is the right number. Okay? You don't have to do this in object-oriented languages. You never have to know how many bytes your object is. Right? That's all taken care of for you. You never had to go to the operating system and say, get me some memory. That was handled by the constructors or by you and those kinds of things. what comes back is going to be an address. And this address is going to be the address of a chunk of memory that's big enough to hold my struct, my node object. And that address is going to go into my variable over here. New node is a pointer to. New node contains an address of a struct node. So new node contains the address of a piece of memory, which happens to be big enough to put a struct node in it. Okay? Malloc does not return a new object. Malloc returns a piece of memory. All right, so let's just imagine that malloc returned 31dog6. Okay? That's just going to be an address. 31dog6 is the address that it gave us. All right, so there's some number. We don't know what the number is. We don't care. We're just imagining that the number it gave us was 31dog6, meaning that at that location in memory. Okay? Okay, so this over here, we can draw this as pointing to, okay? So if I go to 31dog6 in memory, 31dog6, okay, I'll find that. Okay, now what's going to happen is that this struct, this class definition, effectively overlays this chunk of memory. And then I can get items out of it just like I would out of an object with this dot things, right? Okay. So if I could say 31dog6 dot next, that would get me the next variable out of the struct. Okay. If I said 31dog6 dot buff, that would point at the buff variable, that array, inside of this chunk of memory. Okay? So, by doing this, I've effectively done new to create a new object, except that it's just a piece of memory with an address. Okay? And I can use this template to pretend that there's an object. And that's the best we're going to be able to do. Okay? So, new node is going to be the variable that allows us to say 31dog6, right? Dot whatever. Okay? The last thing to mention over here is we need to check to see whether or not malloc actually succeeded. If it didn't succeed, it's going to return what? It's going to return our favorite bogus address. Either give us a real address, real chunk of memory which it gave us, or it gives us this bogus address null. And if we get null, okay, and we can just compare addresses, using is equals the same way we compare numbers. Alright? So if the value inside this variable is this bogus address, then we had an error. Okay? We're done. Alright.